Welcome to the future of space. I'm your host, Daniel Fox. Today we have Emmanuel Duplay. He's an engineering student who's passionate about spaceflight and exploration. He started researching advanced space propulsion during his bachelor studies in Canada at McGill. He's now pursuing a master's degree in astronautical engineering in the Netherlands. He joins us today from The Hague in the Netherlands. Emmanuel, welcome to the future of space.
Thank you. I'm happy to be here.
Now, let's start with like all the other interviews and give me your three words to describe space.
The first word that comes up immediately is awesome, but awesome in the original sense of the word. So it's really you step outside on a clear night, look up at the stars, and it's just wow every time. Like it doesn't get old. So yeah, awesome is really the first word that comes to mind. Secondly, I would say it's the future to me. I don't really envision a future, especially for humanity, that doesn't involve stepping out, flying out into the cosmos and really settling other worlds. To me, that just I can't really imagine a future where we don't do that, and so that's a really big part of space to me. And finally, I think the last word would probably be a challenge. A challenge, obviously, for engineers and scientists because um, you know you got to develop spacecraft, the ways to actually live and work in space, obviously, but also it's a challenge for society. I think going out into space is going to bring up a whole suite of questions and problems that we can't even imagine at the moment. And I think that even as a regular human, that's going to bring up questions and problems um, that we don't have the social tools really to deal with at this point. So that would really capture it all.
Now, before we get into some of the stuff that you and your team are working on, um, I want to talk about, I want to know from you the reason why you think going to space is important. And I think obviously you're from a younger generation. Your generation grew up with a lot of the narrative around climate change. And even right now,
Mhm.
there's kind of a division of the people who are focusing on space is actually at the expense of some of the issues that we have on Earth. Why do you think it's important to go to space?
So I mean, I totally see where they come from, and I mean, I myself, full support of green initiatives and making sure we live on we have a sustainable way of living moving forward. Um, and so I totally see the issue that we got to worry about our own planet too. And to that, I always think, well, one doesn't prevent the other. For one thing, not only does one prevent the other from happening, we can do both at the same time, but also they actually there's a synergy there. They help each other out. For example, a lot of the space technologies developed by NASA for the Apollo program, this has real consequences, benefits, right here down on Earth. The most obvious example of how really space tech helps protect our planet actually is, we have a whole fleet of weather satellites up in space that help us track the evolution of climate change. They help us track deforestation. They can help us fight, leaks of methane gas. That if we actually plugged up these leaks, we could have a real like quick benefits for climate change if we actually use these technologies to help us out. So to me, there isn't. I don't see this as like one against the other, and I think. Yeah, that's one thing I want to say to people who ask me this question is that's they don't have to be separate.
How did you're working right now in propulsion? You have an engineering background.
Hmm.
Um, were you always interested in space from a young age, or was that a kind of with the economy and the future opening up? Now you saw that there was a good opportunity, or were you drawn to the stars from a early age?
I'd say it started really young. Yeah. As a child, I was very curious about everything. I loved watching documentaries, just learning about things, whether it had to do with all kinds of science or engineering, didn't matter. But eventually, I really got drawn to the aerospace side of all that. I mean, my dad was a pilot, so maybe it's genetic. I don't know, but yeah, I got really interested in aviation and spaceflight as well. Uh, that kind of was a background interest of mine throughout high school, and then if people ask me like the single if I had to give a single reason as to why I'm doing what I'm doing right now, it's a game called Kerbal Space Program. I don't know if you've heard about it. Yeah, it's a little silly to say that, but I played this game, figured out building rockets, planning missions. That's fun. Um, and at the same time, SpaceX was really starting to launch Falcon 9. They made their first landing, and so um, that's when it really clicked that maybe I'm good at physics, good at math. Maybe I should study engineering and then try to work in the space industry.
And what led you to the propulsion aspect of it? I mean, there are obviously various different fields, and now you're working on propulsion, which led to some
Mhm.
pretty big media coverage that we're going to be talking soon. But why propulsion? What was attractive to propulsion?
So my bachelor's degree was in mechanical engineering, where so it's not necessarily focused on flight. But from that, I got a fairly strong background in thermodynamics and fluid dynamics, and I ended up working with a professor who was an expert in uh, you know detonation, propulsion, uh, and all of these fields. So I'd say that I had the background to get into it. Not necessarily because I was seeking it out, but just from my studies. And the other side of it is also that propulsion is really what allows you to do anything in space, right? Space is so vast, there's such great distance that you gotta um, travel through, and that you need the right kind of propulsion to get where you want to go. Because if you don't have it, you end up, you know, in empty space, far from everything, and there's not much to do there. So it's a key driver in what we can do out there, and that's why I think it's really interesting and really important.
Do you think that we're due for a groundbreaking development in mobility and propulsion? Because we've been kind of living under the same um, concept of moving. Either it's usually back on Earth is on the wheel, or we have the plane, or when it gets to space, it's a rocket. But we haven't had these kind of that groundbreaking next innovation that would change really mobility and the way that we move. Do you think that we're just about to kind of? I mean, obviously you're working with the laser, and we're going to be talking about that. But do you think that we're about to change the game pretty soon?
I think soon is a little difficult to say. I don't think we're at like a breaking point where there's going to be a big breakthrough in all of that. It's very progressive, and I think the current way we travel through space, so with big rockets, chemical engines, or electric propulsion, that's gonna be good enough for what we want to do for our first steps on Mars, for instance, for the next decade or two at least. Um, but I do think that we need to be working on more advanced propulsion systems that can really open up the solar system for us. So it's really a matter of doing the background work right to enable these big developments in the coming years. Now they're not going to see, actual use very soon. Hopefully they'll see use in my lifetime, but I'm not like holding my breath for it. Yeah, I do think this needs to happen eventually. I don't think that it's going to happen tomorrow or next year.
Well, maybe you have better chances of seeing it than I got 50 years, and you get many more years than I do. So hopefully you'll get to see it during your time. Now let's talk about what you and your team have been working on and made the media recently with this technology of laser traveling to Mars, a technology that could reduce dramatically the time getting to
Mhm.
Mars. So please share with us um, what it is and how does it work.
Right. So the concept is called laser thermal propulsion. Um, and to start with, I have to talk about another propulsion system called you could call it light sails or laser driven light sails. So you've heard probably of solar sails where the sun's light can actually push these, and you basically get free propulsion. It's slow, but it works. And a couple of years ago, there's been talks about something called breakthrough starshot, where you use a very large laser on Earth to push a light sail out to other stars, right? So because we have this big laser, we can actually apply way more power on that sail than the sun could, and so we can accelerate that sail much faster than we would otherwise. um, and so my research group that I joined at McGill originally started working on figuring out some mechanical issues with this concept and seeing what we can do to solve that. But we also thought, well, it would be nice to have ideas that we could test out with this giant laser, maybe in between, from the tiny little laser prototype to you need kilometer wide lasers to actually do these interstellar flights. It would be nice if we found applications for a 10-meter wide laser that's much more accessible to build, and that's where laser thermal propulsion comes in. What's great is with that 10-meter laser, the power requirements are lower, the size is lower, and you can still do very interesting missions out in the solar system. Right, you can drastically increase the speed at which you get to different parts of the solar system, and yeah. So the idea is you have this 10-meter wide laser array on Earth again, um, and you beam it to a spacecraft in orbit. That spacecraft can capture the laser with a big mirror and focus it into a thrust chamber, almost it's very similar actually to just a regular rocket engine. And that laser, you just use it to heat up propellant, hydrogen in this case, and it's a big steam kettle, right? Eventually, it gets so hot it just shoots out the back, and then you get propulsion out of that, and that allows you to get pretty high thrust and high efficiency actually in your propulsion that you don't really have at the moment. Like currently, you either have not very efficient but very powerful chemical rocket engines, or you have extremely efficient but not very powerful electric uh, motors. And this actually goes right in between, and that's really what enables sending large payloads to say Mars in 45 days, for instance.
Now, a lot of people when they think of laser, they'll think of science fiction and something that can cut through
Mhm.
material. I imagine that laser that you shoot to a spacecraft, it's not a lightsaber that's going to cut if there's anything in between that's going to destroy it. How does it? What is the reality of it of that laser being shot to space to that spacecraft?
So we picked out a specific wavelength for that laser. Well, the people working on Breakthrough Starshot picked out a wavelength in the near infrared spectrum at 1 micrometer, and it happens to travel through the atmosphere almost unaffected. right? And that's why we picked this wavelength, because we don't actually, it's not good for us if the laser is affected by it affects the atmosphere, because that means we lose power on the way to the spacecraft. And so we specifically pick a wavelength that goes right through without affecting anything, unless, of course, something flies right in the middle of it. But yeah.
Now, and how far can that connection to the laser um, happen? Like once, obviously, it starts to get the speed and on its way to Mars, I assume that the laser won't be able to connect or propel the spacecraft. So how far can it get with that connection?
Mhm. Um, it's really a function of the size of your laser array. So we're looking at basically the kind of size, the maximum size of the minimum spot size, we call it, that you can shine on an object at X distance away, is going to be proportional to the diameter of your laser emitter. It's also a function of wavelength and so on, but that's what really governs it. So with our current study, we envision a 10-meter wide laser array at 1 micrometer of wavelength, and the spacecraft itself has a reflector that's also 10 meters wide. If you run these numbers, you find that its approximate range is about um, it's 50,000 kilometers in altitude, and that's more or less where the GPS satellites orbit. Yeah, and past that point, it's not that suddenly you can't get any laser power anymore, but now you start losing a lot of it because it really spreads out. But yeah, and if you want to actually go further than that, well, you need to build a bigger laser, or you need to build a bigger reflector, or you need to change your wavelength.
Would it be feasible to think that at some point there's a series of relay, like at different stations, like you leave the Earth and then there's another laser starting from the moon that picks you up, and then we have these kind of other points on the way to Mars. So that you're starting with one, but then you get picked up by more on the way that just keep propelling you forward. Would that be a possibility in the future?
Yeah, in a sense. I think it's not required, at least when it comes to getting to Mars. In our current mission design, where we're thinking, we've got one single 10-meter laser array on Earth, um, and you turn it on for 1 hour, and that's enough to shoot the spacecraft out to Mars. Uh, what would be great is to also have that laser array on Mars to slow down the spacecraft. And of course, if you want to go maybe further out and you want to get there fast, yeah, having a network of these laser arrays throughout the solar system, like the big all bodies in the solar system with these laser arrays, and then having people traveling through the system, just flying by an asteroid or a moon, and just getting a little push from that laser to get where they need to go.
Now, often when we see lasers in the lab, everything is so extremely precise. You have these mirrors, they're moving around, there's a lot of going in different places, but everything is so precise. Is it the same thing if you're going to shoot the laser at that spacecraft, or there's room? I mean, it's you get the mirror, but the precision is not needed on that level.
So there's definitely a lot of precision involved in pointing your laser array at the spacecraft, right? Um, it's a tiny point in the sky, and you need to just get right on that. So to help with this, we'd put, of course, some sort of beacon on the spacecraft to help the laser array actually narrow down its aim onto it. And now, we're not really working on the laser array technology ourselves at McGill, but researchers at UC Santa Barbara are really working on this other side of the equation where, yeah, you need really precise tracking on the laser array. But once that laser actually gets to the spacecraft, we don't believe that you really need a highly precise mirror like the kind you'd see on James Webb, right? We have our concept has this inflatable reflector, which it doesn't have like optical quality. Of course, you're not going to build a telescope out of it, but we believe it's actually enough to focus the laser into the chamber and get a good enough focus to heat our propellant to the temperatures that we need.
Now, you just said an inflatable reflector.
Yeah.
How does that work?
So inflatable reflectors, they've been considered already, a few decades ago already, um, mostly for telecommunications and solar thermal propulsion, which is very similar but using the sun. And yeah, the advantage of this is you can pack your big antenna into a little package, and then once you're in space, you just blow it up like a balloon. It just expands out, and then boom, you've got a nice parabolic reflector, and you can use it as an antenna or as a mirror, whatever you want. Um, and so there's been experiments done in space and on the ground to see, how well that works. And it's not like it's a trivial, simple problem because there's stability issues involved with this that still need to be worked out. But aside from that, I mean, it's about as simple as you imagine. It's just you inflate your antenna and then that's it. Um,
Are you and your team also working on the propellant that the laser is hitting, to create that push? Are you just working on the laser aspect, or you're really working on the entire equation? So the laser, also the reflector, and the propellant.
yeah, so this study was really about doing kind of the preliminary design of like a whole spacecraft that would use this technology. And so we really focused on the key components, which would be the reflector, the thrust chamber, and just doing the math on like how much propellant we'd need, what kind of other systems would be required on the spacecraft to make it all work, and ultimately get some sort of a mass estimate for this basic spacecraft as like a lower bound to how light we can make it. Because really, what we want is a system that for the amount of power it can manage, we want it to be as light as possible. Right? It's a figure called specific power. It's called labeled alpha in our paper. And if you look at, it's often used for electric propulsion systems, where you have these alphas of about, you know, at best 1 kilowatt per kilogram, or no, 1 kilogram per kilowatt. And you want it as low as possible, right? You want it the least amount of kilograms per kilowatt of power. And we were hoping to, show that we could probably achieve, zero point 0.1, zero point zero 0.01, 0.001 kilogram per kilowatt. And that's what we've been able to show in a way. At least we've very promising figures that show that it might be doable. And with that kind of specific power, you can really uh, go out into the solar system. You're pretty much unlimited. Um, yeah.
Do you think the technology will have applications on Earth also? Can you see a future where that technology is applied to perhaps plane or other ways of moving around, but on Earth?
Yeah. So the concept of directed energy in general, which is remote power essentially, and if you can make it work, it's very attractive, right? You could have airplanes that don't need to carry fuel, or well, maybe they would, but uh, or you could have cars that don't need to carry, their energy source. It's a little more, I think, complicated when it comes to say your day to day life because your power sources are so much more accessible. Um, our engines are so much more efficient, and we already don't need to carry as much propellant in a way, right? Airplanes, they suck air out of the atmosphere to actually burn their fuel, whereas on a rocket you need to carry that air with you, and that's a big problem, big disadvantage. So I don't think on the ground um, the benefits of directed energy are good enough to justify how impractical it would be to have these. I mean, it doesn't have to be lasers, but if you imagine having a bunch of laser arrays just shooting at things in the sky, it's a little anxiety inducing. So I'm not entirely sure if there are like great applications for it down here, but I do think the reverse. So getting energy in orbit and then beaming it down to the surface of the Earth has some limited applications. It would be a great way to deliver power to really remote areas, remote communities, scientific bases in Antarctica, military bases. So that's something that's being looked into actually. They wouldn't be using lasers; they'd be using most likely microwaves to beam that power down. So there are other applications to directed energy other than propulsion, um, but I'm not sure you'll see them in your day to day.
Now, so the research and the work that you did got a lot of attention, got a lot of media coverage. So, what is next now? What was the kind of the outcome from that attention? What did it bring to the team, and what are you all working on right now?
So what the team really wants to do at this point is to start doing experiments. My supervisor's background is really into experimental research. So we have a lab with equipment. We're getting a 3 kilowatt laser delivered sometime this year, hopefully. And the idea is really to do any experiments that could help kind of validate the models that we have and possibly even build like a prototype thruster. So that's really the direction we're going into, and we've gotten some attention from other researchers who'd like to collaborate. So we're looking into that, and yeah, hopefully this can really kick off a big research effort in that area.
If there's someone that's watching and they want to do something, what is it that the team needs right now? I mean, you mentioned you're gonna get the delivery of a big laser. You get some interest from other researchers. What else the team needs right now?
So we're still in the academic research phase, right? So it's a little hard to say, oh, well, just donate to so and so to make this happen, or we can't like really have a Kickstarter for it at this point. But I think we're doing our research in Canada, and there's this program in the U.S. called NIAC, which is run by NASA, and it's basically an institute that funds research on really advanced concepts. It's the Institute for Advanced Concepts, um, and they fund ideas like this on propulsion, on all kinds of technologies for spaceflight, such as I think the latest one funded a study on 3D printed spacesuits. Um, and so this is the kind of thing that could where our project could really fit in, and we could make a proposal. Unfortunately, because we're Canadian, we can't actually participate into this program. So I mean that's why collaboration with American research institutes is great, but also especially for Canadians, it's pushing, for example, the Canadian Space Agency to have a similar program, or pushing NASA to expand this program to Canada or other partner countries, things like that. But ultimately, it's still research, and so it's down to it's down to getting funding from the sources that research usually gets its funding from.
So we need to let Canada know that you need to create a program, investment program like the one down in the U.S., so it can support Canadian teams. Now, more on the personal level, if you had the chance to go to the moon, or if there's a position that's going to open on the orbital space station, would you go and work there?
Oh yeah, absolutely. No questions asked. Maybe a few questions, but I'd be on board. Absolutely. Uh, I was thinking if somebody asked me whether I'd want to go to Mars with no way of coming back and just spend the rest of my life there, I wouldn't immediately say no. So I'd consider it, but I'm definitely very would it'd be a dream to actually go out there and get some work done. I'm not so interested in going as a tourist. Um, I really want to go and have a mission, an objective to do.
Yeah, when it comes to Mars, usually it depends if someone is in a relationship, the situation of the partner, if it's a one-way trip or a round trip. I know that myself and my wife, it's more the idea that once we get into our 90s and we're about, we're okay with doing, leaving the Earth and never coming back and just seeing the stars, then we can do that. But going to the moon, absolutely, or even going to space, that is definitely on our list, and hopefully we'll get to see it. Um,
Hmm.
Emmanuel, what's the general mood in your generation when like talking about space or working in space? Is it pretty common that everybody is excited about it, or are you kind of in a little group focusing on the big vision? Do you see some kind of camaraderie within your generation?
That's a little hard to answer for me. I think I've realized um, over the years that I'm definitely way more into this than some other people my age might be, and that's somehow always a surprise to me. I don't To me, it doesn't make sense. Like, how are you not crazy about this as well? So I wouldn't say it's something that everybody thinks about, or everybody, yeah. So some people don't even think about it. Right? They might see SpaceX in the news once in a while, but they'll just see you know whatever. Um, so if anything, some of us might be indifferent, but I guess that's kind of normal at any generation for any topic. I do see, some people are a little more skeptical about what we're doing, about what Elon Musk is doing. His personal profile is a little controversial. Um, but I'd say among, other engineering students, it's pretty much unanimous excitement about it. And yeah, just a lot of hope for the future.
Yeah, I think the one, and that's part of my goal with the future space and the writing that I do. There's We are going to space because nature wants to go there. I mean, from the perspective of life on Earth and in the universe, it never really wanted to be limited to the planet Earth. There are other life spots. I do believe that there are other life spots in the universe, and life inherently wants to connect. So as soon as you can get a species that takes life, basically taking it from a single planet to a multi-planetary planetary, in the same way that cells went from single cell to multi cells, and then evolution kind of took a quantum leap. Um, Life wants to go out. So we're just the ambassador, we're just the medium through which life is going out. And it's not, yes, now we're talking about the earth, but before that, talk and then think of any family who, they have their kids, and then they have their grandkids, and then they have their great great grandkids. Not everybody stays under the same roof. Everybody has to leave the house at some point,
Mhm.
and it's not at the expense of the parents to stay behind. It's actually for the benefit of everyone. All this talent that's just being exported, and these children now are developing their own families, and then all this knowledge and this information and the resources are being shared for the support of the house, where they grew up in. So it's really not at the expense of the other. It's really for the support. And whether the technology, but also mining, as soon as we can mine off the planet, is going to be at the benefit, is going to take the stress off the planet. Because even this vision of a battery economy that we have, if we have to extract all this resources from the planet Earth, is going to create as much damage, but in different ways. But if we can do it, on the moon
Mhm.
or on an asteroid or another place, and I do believe that there's going to be some recycling technologies in space that are going to be extremely beneficial for the Earth, because your resources in space are extremely valuable and scarce. Yes, you can throw out pretty much anything here because you can get it from a gross, any store. But in space, that atom of carbon that you have, that you bring with you, you cannot throw that out as if it was just something that you can replace. So you're gonna have to figure out how to recycle that atom of carbon in various ways, whether through food or any material. But it's that pile of garbage in your space. You're not gonna open the door and throw it out. You're gonna have to. There's gonna be a necessity because
Yeah.
it's more valuable than gold. So now it's really interesting to see the the narrative that is being developed, but I think that we have to put the human narrative, the story in it. It's not just about science and billionaires. And yes, billionaires are always there first to create opportunities, and that's their goal. That's their place in the equation. And then you have the other people to tell the stories. So right now you're in Amsterdam at the Hague. How many more years that you have left in the program?
I still have. Well, I'm just finishing up my first year. Still have a few courses to finish mid-April, and after that, it's internship and then working on my thesis for the next year.
Is there one company that calls your heart for the internship? If we can make some connections.
I don't even want to start talking about internships. It's been such a headache for me, actually. Um, no, I've been sending out applications to all the big new launcher startups. So of course SpaceX. I had a few interviews at Relativity Space, and then other. I also applied to companies in Europe, often focusing on like small satellites. Um, but yeah, at this point, it's really just about getting experience. If I could get an internship, just getting my hands onto a problem, getting into the industry, and just really getting that experience. But I'd say yeah. I was gonna say yeah. There's also the option of I was talking about researchers who want to collaborate with us on this project. So um, I'm also looking into possibly just like framing it as an internship for the summer and then moving on and doing my thesis, basically just expanding on the work that we've done, that we've published last year.
Well, I'll make sure that I can funnel your way any connection that you need. Um, already thinking of some people,
Thanks.
so um, whether you want to start your company or you want an internship, I will. Well, Future Space will help in any ways that we can. So don't hesitate in asking.
Thanks.
Emmanuel, it was a pleasure. I know it's late for you. I see that you have the rocket just on top of your hard rope there.
Yeah, just up here. Yeah,
Are you following the development of the Artemis? And did you actually put your name into the awareness campaign that they have?
I don't think I did it for Artemis. I think I did it for the Perseverance rover, but I don't think I did the little ticket, right, where you put your name and it's
Yeah,
sent off with it. Yeah, no,
the boarding
I'm not sure I
pass.
did it. I
Yes.
think I might have forgotten to do it. But I am following it. I saw a bit of the rollout of SLS, and for all the controversy around it, it's impressive. It's inspiring, and it's awesome as well. So yeah,
It is awesome. I think it's a wonderful way to finish this conversation by reconnecting to the your three words to describe space. It is awesome. Emmanuel, thank you so very much for taking the time. I know it's late, in Europe right
not
now,
a problem. It
so
was
I really
a
appreciate
pleasure.
it, and wish you all the luck, the best of luck in the work, and we look forward to seeing the development and how your career is gonna blossom into space. Thank you so much.
Thank you so much.